Good morning, everybody, and welcome to today's panel discussion in the Energy Transition Zone at COP28. My name's Adam McTavish. I'm Sustainability Director at Curry & Brown. Today we are talking about data centers, and data centers are some of the world's most energy-intensive buildings, but they also underpin much of our digital lives, whether that is a storage place for our digital photo albums or for the delivery of software as a service applications, or increasingly artificial intelligence platforms. We're going to consider the impact of these buildings on climate change and the opportunities that exist to reduce these effects and to embed data centers more effectively into our built environment. So in 2023, we have around 8,000 data centers globally, and they're already consuming over 1% of the world's electricity generation. We anticipate this level will double in the period to 2030, making them one of the largest contributors to energy consumption as a single sector of all the sectors that exist. We know that global power demands have doubled since 2015 and are likely to double again by 2030. So at that point, the emissions from data centers and the data transmission network that they work within will be broadly equivalent to the carbon intensity of the aviation sector today, giving a real measure of scale of these facilities and the energy that they consume. Virtually all of the energy that is consumed within a data center is turned into heat, or is used for cooling of the data center. Okay, I'll skip the slides and just keep going. Virtually all of the energy used in data centers is converted into heat, and that isn't turned into heat is used for cooling. This means that globally, the data center sector is generating around 140 terawatt hours of heat each year, which, to give you an idea of the scale of that, it would be the equivalent to providing heat to around 10 million homes. Beyond the energy use within the facilities during operation, we know that the embodied impacts of construction are also significant. And work done by Curry & Brown, in fact by one of our panelists this morning, indicates that the scale of those impacts may be as high as 80 million tons of embodied carbon in the US alone in the period through to 2030. Okay, thank you. So we can see that data centers have a huge impact on our built environment and on our environment more generally. So the question we have to ask this morning is, how can we reimagine the role of data centers in our built environment, and how can we radically reduce their impacts? Now, I'm fortunate this morning to be joined by three excellent panelists who have some really interesting perspectives on that question, and I'm really looking forward to the different areas of research that they've done and then hearing them talk about those and the discussion that hopefully that will follow. So our first panelist this morning is Dan Epstein, and he is, I've known Dan for nearly 20 years now, believe it or not, and he's a sustainability leader. He has delivered some of the most impactful sustainability programs around the world. I suppose highlights might include being the head of sustainability for the London Olympics 2012. And interestingly, he's also been involved as a sustainability advisor on COP28 itself. So has been helping to reduce the impact of this event that we are currently attending. Today he's going to talk to us about the project that he's currently involved in West London, where data centers are being effectively integrated into the built environment and hopefully providing real benefits to both the data center operators and the communities in which they're located. Our second panelist is Mark Wattenberg. Mark joins us from East Coast, USA, and it's currently 2 a.m. there, so many thanks for getting up so early, Mark, or staying up so late, whichever it is, to join us today, and it's very much appreciated. Mark has around 30 years experience delivering real estate programs for major corporate clients. Those include Philips and Nike, where he's delivered programs in over 30 countries. He has a particular interest in the tech sector, and in his role as the Director of Sustainability for our Americas region, he has been doing research in this area, looking at the embodied impacts of data center construction. Our third panelist is Richard Palmer, Director of Global Sustainability at Introba. Now, Richard has worked on both buildings and infrastructure for the last 20 years, delivering transformational sustainability programs in Australia and around the world. He's going to talk to us today about work that he has been leading as part of Introba's Impact Fund, which is their own internal R&D investment fund, and has been looking specifically at the embodied impacts of different servicing strategies for data centers and the opportunities that they create for reducing their impact. So welcome to all of my panelists this morning, and let's move over to the chairs, and we can have a conversation. Do we have another microphone? Thank you very much. So, Dan, if I can start with you, please. Can you just talk to us a little bit about the work you've been doing in West London, how it came about, and the impacts and opportunities that you think it presents?
Okay, I guess just a little bit more background. I'm really interested. Today's Built Environment Day actually here, and I'm really interested in the way in which we tackle climate change at the sort of city level. And as you said, Adam, data centers are becoming a really big part of sort of energy demand. I've been doing some work for a quarter of London through the Greater London Authority, looking at how 11 boroughs across, there are 32 boroughs in London, 11 boroughs can transition to zero carbon. And we've been looking at transport pathways, we've been looking at power pathways, we've been looking at heat pathways, we've been looking at retrofit pathways. But the biggest issue we face at the moment in West London is absolute capacity constraints on power, and yet we're trying to build another 50, 60,000 homes. So there isn't enough power at the moment for those homes. And when you think that those homes also are all trying to go electric from a decarbonized, so electric from a energy perspective, from a heating perspective, and also we're trying to move towards EV vehicles, the load demand is kind of growing, as you sort of said, Adam, massively. So we did a study to look at what the future projections for load demand would be, and it grows sixfold. But what's really worrying is that the really big driver of this demand is 5 new data centers which are being built in the heart of West London, in order to allow us to upload the photographs that we take every day. More photographs now in a day than I think, it was the history of photography over, up to a couple of years ago. So it's kind of extraordinary how it sort of accelerated, but all the YouTube downloads, etc. So it's a huge amount. 80% of the increased demand for energy, power, is coming from to fuel these data centers. So we have these data centers coming into West London. We have a real issue, and we've been trying to think through how do we therefore deliver a decarbonized future, but also meet the capacity constraints. And so there are a number of things we're trying to do with the data centers, reduce the PUE, the power utility efficiency,
power use effectiveness,
of the data center. So working with Google, it's very interesting. They've gone from a power use effectiveness, which is the way we kind of measure the energy efficiency really of a data center. But they've gone from on a logarithmic scale from an average of about 1.7, 1.8 PUE down to 1.1 using AI. So much, much more efficient. But the other things we're trying to tackle are but we've got a real sort of issue, and we kind of recognised actually that, as Adam said, there's a huge amount of waste heat that is generated through the data centres, and so we've been developing a project. It's a £110 million project to take the waste heat from those data centres and deliver it to, and we've modeled it, and we think it can deliver enough heating and hot water to supply 25,000 homes, a hospital, two hospitals, the Hammersmith Hospital and Central Middlesex Hospital, and a prison in the area. So, and plus the industrial uses. So it's really interesting, but it requires different technology. It requires an openness on behalf of the data centers. The data centers are essentially a very, very sort of secure, very secure centers. They're sort of selling these boxes that nobody can enter, and they usually have fences around them. So you've got to have an interface with that. And at the same time, these data centers are coming into the sort of the center of the city, and we're looking at ways in which we can integrate that big box development that has no windows at all and takes a whole block of, you know, the city and integrate it into the city properly. So redesigning it, rethinking it from those perspectives. So it's a huge issue. It requires us working with lots of different stakeholders, but we believe we've got a scheme that will, now we've raised £50 million so far. Halfway, we just did a procurement to bring some private sector funding in to deliver the other £50 million, £60 million. The internal rate of return on that investment by the heat network operator will be about 10%. So it's a really investable piece of infrastructure if we can get all of the different interests aligned. And the other co-benefits that it delivers are, if we don't take that heat, apart from needing additional electricity, which is going to cost £400 million to bring to the area, so this will slow it down. It won't deal with it completely. We need to be thinking about smart energy saving sort of systems, etc. But if we can deal with that, it helps to relieve that problem, but it also helps to relieve the urban heat island impact. So we had the first 40-degree temperatures, feels cool compared to here, but 40-degree temperatures a couple of years ago in London broke all the records, and data centers and other developments are just contributing to that. So if we can recycle that heat and displace the heat that we need in, you know, for buildings, then again we also have that massive kind of potential benefit.
Thanks, Dan. That's fascinating and sounds like a really exciting opportunity. I'd be really interested to know how the conversations that you've had with data centers have gone. Are they open to this idea? Have they engaged positively, or have you sort of dragged them to the table?
The reality is that they let's
not
be,
a leading
let's be,
question.
No, but let's be really honest. It's taken about 3 years from. I mean, I started the project. I kind of, you know, I was kind of geared with thinking about how do we make this area sustainable, and I was kind of looking for. And if you look at you do an energy audit. 75% of the energy is really for heating and hot water of buildings, you know, in a predominantly residential area. And so it was obvious we can deal with electricity, and we'll talk about that a bit later. Our electricity network is being decarbonised. It's reduced by about 50% over the last 10 years, the carbon intensity of our electricity, and it will become more and more decarbonised. So electricity isn't really the problem, it's the supply of power, and it's heating and hot water at the moment, and cooling eventually. I mean, we're going to need cooling. So we started thinking that through, and it was, you know, we looked at ground source heating, we looked at taking heating out of canals, we looked at taking heat out of industrial processes, but it was really obvious that data centers are the most concentrated and high potential resource for heating in our location. We approached them, the developers, and they had slightly different kind of views. It's interesting, most data centers, and this is one of the issues, are not initially developed by the end user, the operator. So the Microsofts, the Amazons, the Googles, etc., are operating these, and they all have zero carbon commitments, but they're being developed by developers who are sort of traditional sort of real estate developers, who worked a very prescriptive approach. They want to keep us away from the operators. So we had a really tough time because in their specification, these data centers need to be absolutely secure. So we had a really difficult time persuading them that bringing a new utility, a heat network, into the data center was a really valuable thing to do. It took about 3 years. And actually, I think most of sustainability is the big issues are human, not technological. Having persuaded them, I then tried to persuade them that they should all be carbon offsetting and investing in the project. So they did their carbon calculations, and they said the carbon offset budget would be $350,000. And we said, but you're not measuring the load for the actual, for the data center itself. And they said, but that's industrial, so it doesn't come under carbon offsetting. And we said, well, if this was a commercial office, it would. And so we said, actually, you really ought to be providing $7.5 million, $10 million, £7.5 million as a contribution. The developers said absolutely not. I went through the planning process, really difficult. But then Microsoft came in, and the operators, and they immediately said yes. This is going to deliver part of our decarbonization plan. Frankly, it looks really cheap. It's a brilliant way of using the wasted heat. Let's get on with it. And by the way, rather than giving you a couple of gigawatts, we can give you 8 gigawatts, and we'll re-engineer our processes. So I think the lesson is, if you can get to the right people who are really trying to do stuff, it's really easy. But normally you have to get through 5, 6, 10 layers of people who don't want you to do the right stuff because they think that you might undermine the commercial case, you might undermine the opportunity they have in selling this data center to to an operator, etc. It's just not joined up. So here we all are talking about this sort of stuff, and actually, how do we get it, filtering through the layers?
That's so interesting, and I think one of the areas that we looked at was about the metrics. You mentioned the PUE as a way of measuring data center efficiency, but it only captures a small fragment of all of those opportunities and impacts. So I think changing that discussion about what makes a good data center would maybe help improve that line of communication a bit. That's brilliant. Thank you, Dan. I'm now going to take my heart in my hands for a moment and see if our connection to the US is working, and see if I can bring Mark into the conversation now. Morning, Mark. Thanks for joining us again, and I'd be really grateful if you could talk to us a little bit about some of the work you've been doing. And I know you're doing a lot of modeling around hyperscale data centers, looking at the opportunities to reduce their carbon footprint, and also on some of the points that Dan mentioned around location and how we can address impacts by smart thinking about where we put data centers as well as how we build them.
Thanks, Adam. Can you hear me all right?
That's perfect. That's perfect. Thanks, Dan.
Okay, good. So there's a bit of a lag probably, but I'll just keep talking and hope I'm fixed. So thanks everybody for joining us, and Adam, thanks for the intro. Dan, it's one of these that, wow, I don't have to say anything. This guy just said it all.
I'm going now.
Thanks for dropping in. Much appreciated. But I also said that for us in the U.S., that we have been focused a lot on modeling, in particular, embodied carbon in new build data centers, mostly at the hyperscale level, which means somewhere north of 25, even 30, maybe 50 megawatts anyway. It's starting to go up even higher than that as each rack continues to improve and or get worse at using energy, depending on how you look at it. So we've really been looking very closely at what we can do in terms of what's available to us today to change the embodied carbon footprint. And reality tells us that it has its limits, but that doesn't mean there aren't a lot of options. And what we found really is that, and I know this is going to shock everybody, but the less we build, the less we get, the less absolute impact that we have. So here in the U.S., almost every data center is being built way outside anywhere where the heat might be recapturable. It's tough when at 2 a.m. It can be recaptured. Most of them are sitting out in really large tracts of land in really nice places like the middle of the desert. So they can get at all kinds of different alternative sources of carbon-free energy if they invest in it, which is happening. I'm sure everybody's seen some of the work that Google's doing with geothermal in the middle of in Utah. I'll get to it. But reality is there's only 700 hyperscale data centers in the world today. That'll probably double in the next 10 years, less than 10 years, till 2030. So what we tried to look at is where can we actually get beyond what we can do today? And what we found, I think we've done about 24 separate models with different types of materials from 4 different major players in the hyperscale data center world, who are clients of Point Brown here in the US. And what we've tried to do is compare as much as we possibly can, where things are similar, where they're not, and no surprise again, data centers are pretty much a repeat over and over and over of exactly the same typology and the same basic structure. So what could we actually get at to get more than 25, maybe 28% reduction in embodied carbon? Because that's all we can get at the moment. And again, I'm really not sure outside the U.S., but here we're dealing with a lot of the folks who are making the data center decision in major clients. There's a lot of developers, and they're basically they're kind of going around the country and developing smaller pieces. The largest data centers that we see are being developed by big players, and they're here across the U.S., which I think the U.S. is 30-something% of all the data centers in the world. And every time we turn around, there is a permitting issue that we read about someplace, whether it's in Virginia or it's in the Northwest or it's in Nevada. The permitting issues in terms of being able to access these large tracts of land, where they may even be able to supply their own power, it's a real challenge for them. So back a little bit to the notion of just dealing with the embodied carbon, because really the energy to the folks who know a lot more about it. My training is as a recovered architect, and I've really been building data centers since the early 2000s when I worked for some microsystems. And as it turns out that many of the decision makers are the folks who are actually running the data center. And they are then pushing that up into the top of the company and saying that we want it to be A, B, C, D, and E. It has to be this. Doesn't mean that they are necessarily the right people to make that built environment decision, but they are really the ones that are pushing up the standard. And what we've tried to do then is address the standards for some of our clients and say, how can we build in a lower embodied carbon level into your standards, into your master design documents up front? Because what we've also found with all the studies is that if you can get in early on, it really saves you a lot of grief in the re-engineering to try and push back. I'm just going to say something not polite. Push back on the folks who are trying to engineer it out because they want to keep the cost down, or they need to make sure that it gets done permanently in a much faster way. So if you can put it into the design specs up front, before they even start, you seem to be getting a lot more traction in terms of keeping it in. And I think the last thing that we've now started to find is that if there were the ability to reuse more buildings, and there's an awful lot of building types that are available, certainly here in the U.S. I live in rural Maine, where there's more than 5 million square feet of open, translates into a square meter, sorry, but it's 5 million square feet of just old mill buildings that are unused here. They're manufacturing buildings. That's just in the state of Maine and rural ways. So the ability to reuse takes away so much of the embodied carbon footprint that it's just not on the radar. And then the second thing, as Dan was saying, is that nobody here is interested, at least at this point, in talking to us about locating inside of a place where the heat might be used. So it's all in places out in the hinterlands where there's no ability to use that heat.
Thanks, Mark.
Again, yeah, go ahead.
No, thanks, Mark. That's really interesting perspectives from the US, and I know with a lot of the modelling that you're doing, you're being able to identify sort of patterns within the different scales of data centers, and I suppose maybe the benefit is that the large facilities are more efficient than having distributed centers across 100,000 offices and additional loads there, but the concentration brings its own impacts. And I'm acutely aware that we're probably going through a data center right now talking to you, so thank goodness it's working well. But thank you very much for that contribution. And let me turn now to Richard Palmer. Richard, if you could talk to us a little bit about the work the Impact Fund has been doing, which is really looking specifically at services and embodied carbon and whole life carbon.
Thanks, Adam. I'm going to start high, and we'll end up with mechanical systems in due course. Why do we care about data centers overall? What's driving this focus now? I mean, I think as normal people going about our lives, we don't think a hell of a lot about data centers. We think about aircraft, and we think about office buildings, and we think about coal-fired power stations. Those are the parts of infrastructure that really jump to mind when we think about climate. And I think there are two key things that are happening. The first is a lot of our entities, corporates, etc., are starting to count Scope 3 emissions. And the one thing that we all use, every single one of us, individuals, every single company, we all use the cloud. And the cloud has a very real shadow. It's not immediately apparent, and it is growing. So as we need to disclose, and as companies and countries are becoming increasingly focused on the whole carbon picture, we're seeing a focus come onto digital infrastructure as a previously hidden and now increasingly important category of emissions that touches everyone. And the scale at which it touches everyone is surprisingly large. The second thing that's happening, obviously, is that it's also growing very, very fast. And mobiles, I assume we all have one, at least.
I can see a few in the audience, yes.
And AI and the huge processing demand, crypto, etc. The actual cranking out of calculations and ones and zeros is growing immensely. So we have these two driving forces. Now, when you look at a data center, and Dan's spoken to it already, the operational energy of a data center is glaringly huge. It is an immense load that sits in any energy network, and all of that, nearly all of that, gets turned into heat. One of the really good things, though, is that we can actually decarbonize that operational energy relatively effectively. I mean, it's taken a while, but in many places, most electricity grids, at least, are onto quite a steep decarbonization journey. I mean, it's the great success that is spoken about at events like this. The energy transition is underway, and it is particularly underway in the electricity sector, the stationary generation sector. So we can do that. And I think you see it in all the tech majors, and we see a lot of commitments around the procurement of renewable energy and the RE100, and that is all laudable and really, really good stuff. But the hidden bit of that is that the stuff that we make data centers out of becomes increasingly important. And as the grid does the heavy lifting for us on operational carbon, so the focus on embodied and circular economy emissions that are associated with growing physical infrastructure become really key. Now, the thing about data centers that makes them different from other sorts of buildings is that they are very, very highly serviced. They require a great deal of cooling, considerably more. I mean, you might think this tent requires a great deal of cooling. I would suggest that it does, but I imagine a data center inside this tent would increase that quite substantially. So there's a huge amount of mechanical kit that goes into a data center. Lots of cooling. Not so much heating, but lots of cooling. Now, the thing about gear, now I'm a mechanical engineer by training, so I mean, you can forgive me for that, I hope. But the thing about mechanical kit is that it has very long supply chains. It uses a lot of high-intensity materials. It's got some often quite nasty refrigerants inside there. And so the servicing of data centers is a dominant portion of the embodied emissions. Now, we design mechanical systems, and so we gave some serious thought to this question because we also take carbon quite seriously, as I would hope most of us here do. But the lesson, and we looked specifically at the makeup of embodied emissions in data centers as a looming potential challenge and dominant factor of the greenhouse footprint of the digital infrastructure sector. And we learned a few things. The first thing that we learned was that, structure, yes, structure is important, and how you house data centers is important, but that the mechanical and electrical equipment of a data center could comprise certainly more than half and as much as sort of 75 to 85% of the embodied emissions of that center. And when you decarbonize operations, that becomes a substantial chunk of the footprint of the digital infrastructure sector. The second thing, though, was that like much infrastructure, data centers are built for quite long lives. And that it wasn't so much the upfront day one embodied carbon that was dominant. It was the maintenance-related carbon of the continual upkeep and upgrade and keeping those HVAC, all of that mechanical gear going over 50 years, that was actually the dominant portion of those embodied emissions. The third thing we saw, we looked at a couple of different systems. I won't bore you too much with the details, but there are different ways you can cool. You can cool with air, you can cool with water, you can cool with a bunch of other things. There is typically a trade-off between efficiency and cost when you look at different cooling strategies. What we found, though, was that there's also a trade-off around embodied emissions with different cooling strategies, and it is something that is very seldom looked at. So to the points that Dan was making around deep engagement with developers, how you get decisions made, to what Mark was saying around the role that embodied carbon plays in the data center sector, we take that one step further and we say, well, now actually how you design and your system selection is no longer just an operational question. It is now highly important to embodied emissions. It is dominant in terms of the future emissions of the sector and needs to become a very high priority in terms of climate-related decision-making. So Adam, I'll probably leave it there or hand over to Dan for a chat, but that's really where we got to in our study under the Impact Fund.
No, it's fantastic, thank you.
Can I just make one comment on that?
Please do.
A couple, actually. Three. One is that data centers have got, they are extraordinarily profitable, and they've got resources and they're concentrated. So it's a problem, and they've got typically some very big operators who really want to help tackle this problem. So it's a lot easier than dealing with a diffuse city, if you like. The second is that there's the carbon footprint of all of the equipment. But I think much more importantly, there's also the ecological footprint of mining things like indium, lithium, cobalt, which is coming from places like Myanmar, coming from the DRC, etc. And the footprint is awful. The impact on ecologies, on water systems, on air is just horrendous, and something we really need to sort of look at. So there's another reason for doing this. And then the third thing, and this is slightly sort of from the side, but metal organic frameworks, MOFs, are an amazing technology for cooling. Use about 10% of the energy, should be bolted onto energy centers because the majority of the energy is in cooling, and will be the future. And don't require all of those chemicals. So this is hot off the press.
So we heard it here first, MOFs.
All right.
I'll look out for those. Thank you, Dan. That's brilliant. Thank you to the three of you. And I think what I've taken away from that is there are big impacts, but there are big opportunities to do things better and differently. And I suppose where I'd like to go now is to talk about how we unlock some of those opportunities and what are the ways in which we can, as as policymakers, as at a local level, at a national level, or within the data center community, or as consultants, importantly, how we can try and get those messages across in a clear and coherent way that might get what appear to be achievable and not unviable opportunities to reduce those impacts onto the table to what it sounds like is an audience where you've got a customer who's keen to listen if they can see the opportunities, but maybe they're in a bit of a blind spot at the moment, particularly say the embodied emissions, which haven't been talked about particularly around MEP hitherto. So maybe if I start with you, Rich, if you could just talk to that briefly.
So let me talk to the performance, and I'll let Dan talk to the planning, and then Mark can jump in because his hand is up. At the moment, we measure data centers really on efficiency, and that's an internal thing. It's how well does this piece of kit turn energy into data? Now, that's great, and efficiency is important, and we will get there, and it's an important driver of decision making. But we can add other KPIs into the process by which we assess data center performance and viability. And so we can add embodied emissions as well as operational energy efficiency. We can also add heat recovery potential as a quantified metric. And I think the world of climate finance and the world of how viabilities and feasibility work gets done for data centers can start to reflect those in their financing as well as in their planning. But I think the key thing is benchmarking and assessing new metrics as well as just efficiency. And then I think a great deal will come into planning and permitting and where we choose to put them. So Dan, over to you on how, over to Mark. Okay, Mark, you're up.
I'll say hallelujah on the permitting part. I can tell you that from my own experience of the last at least 25 years, is that the biggest success that we've had in terms of, other than the decarbonization of the grid itself, have been the restrictions and or incentives in the energy codes. So as the energy codes have changed over the last 25 years, we've gotten better and better and better at controlling and managing how we deal with the energy that goes into anything, and data centers are no exception. When we first started putting data centers in various places in Silicon Valley, the only admonition was don't brown out the town. And that was exactly what was happening. It was just too much power. It's at a different level now, but that permitting part has changed. As we're seeing here, now that people are starting to be required to report on Scope 3 emissions, building that back into the permitting process along with the incentive process, like the Inflation Reduction here in the U.S., as they're doing that, now there's a lot more willingness to talk about a variety of different things beyond just the energy code. They'll put it into the building code, which is at least 25 years behind the energy codes here.
Mark, thanks for that. And I wonder, just as a quick follow-up, whether you could talk briefly about the California SB 253 law and how that, because that's requiring Scope 3 reporting, as I understand it.
Correct. That and the SB 261, which is the follow-up for smaller companies. And essentially what it says is that any company with revenue of more than $1 billion globally or anywhere that does business in California, even if it's a dollar, that do business in California, they are going to have to report on all their emissions. Scope 1 and Scope 2 begin for everyone in much more detailed way in 2026. And in 2027, along comes all Scope 3 emissions for all the developers, and they are going to have to report that to the state of California. They won't be able to report it. The second part of the hopefulness here for me, right, is the Securities and Exchange Commission is about to pass a law that will require Scope 3 reporting at a much higher level for any financial risks relative to climate than for almost any company operating in the U.S. So the SB 253 in California is sort of a game changer, and from what I understand now, I'm now a verifier for California. That's what I mean. I don't know, they're trying to have some paperwork. But what's going to then happen is we're hearing an awful lot of clients coming and say, so what's this going to mean to me North Carolina or Virginia, they just expect it's coming next.
Brilliant. Thank you very much. Dan, can I ask you to pick up this point?
Yeah, there are four things, I think. There's regulation, international and national. There's planning and permitting of development. There's finance and there's risk. If I start with risk, nobody building a data center is going to take a risk. It's got to work. And so we've got to, if we're going to get these technologies adopted, we need to prove that they actually kind of work and they get plugged in. The whole sort of development space is risk averse. So, you know, we need really good mechanisms for dealing with that. The second thing I would say is, you know, that actually carbon should be priced at 250 to 300 pound a ton. If we're literally going to take carbon out of the out of the atmosphere, that's where it needs to be. If it was, we would find thousands of solutions for dealing with this, and data centers wouldn't really have, you know, they'd be investing big time. Permitting data centers, the big hyper ones, we've got 4 of them are over 30 megawatts, are coming into city centers. They're not great neighbors. So we really need to be much more imaginative and much more thoughtful about how we integrate them. We need to insist that they're part of the solution, that they deliver their heat properly to the wider community. It should be a requirement. Various other things, you know, generation of PV helping with the grid. There's a whole bunch of stuff that they can do. Every data center has a decent sized data center has its own substation. You know, so that's the third thing. And then I think the last thing is regulation. Frankly, nobody does anything. You know, and this is the point about California, no one does anything unless there's real regulation. Carbon will start to be tackled, biodiversity will be tackled, materials, circularity, once it's mandated. You know, so if we really want to get transition, and that's not just for data centers, but I generally think the data centers are quite an easy use case, we need those 4 things.
Brilliant, thank you. And I'd like to just quickly touch back onto a panel discussion that we had yesterday, which was around decarbonising the health sector. And I think it's really interesting that 2 of the end users that your data centres will be providing low carbon heat to will be hospitals. And of course, the resilience that you need to run a data centre means that heat supply is also very highly resilient, I would imagine. So that kind of joined up approach that they can be a bad neighbour or they can be a good neighbour depending on how you think about them and how you plan and work them into your development.
No, I think that's right. I think we're lucky because I'm looking at 2 projects actually. One is the data centre. I'm also looking at I've set up another project which is taking heat out of the River Thames. Guy's Hospital, which is one of our biggest inner London hospitals, is currently using gas at 140 degrees. I mean, it's the most inefficient heat network. They are on their knees financially. They need cheap ways of decarbonising and also saving themselves money. What's really interesting, it's the same with the data centres and setting up an energy network, is that the business, the infrastructure developer, pays for the capital cost and then sells the energy to a hospital. And the hospital is a fantastic end user because they're there for a long time. They're a AAA customer. You can amortize, you know, a 30-year deal, a 20-year deal to buy your heat, go and raise the capital from that. So they're a brilliant sort of, they're a brilliant partner. They don't have the capital. Infrastructure investors do. And so if you can kind of work this, and this is about how the architecture, not just of the data centers, it's the architecture of finance, it's the architecture of investment and of development, you know, around a city that requires strategic sort of planning. And planning in Britain has become so unstrategic, it's unbelievable. But if we can design our cities much, much more strategically around resources, around finance, around people, around communities, around health, around transport, you know, so that we really understand what systems thinking is, we will make a step change, and data centers can become part of that ecosystem. But currently, they're a separate thing on their own, totally divorced from everything else. And the really big, difficult job is actually pulling all these different players together.
Dan, just to add to that, I think, you know, in any environment that they find themselves big data centers are the biggest guys in the room in terms of resources. And so that's why they sit. I mean, so are hospitals quite often. And I think from a planning perspective, from a regulatory perspective, we've often put the big difficult things in little baskets on their own because they're economically important, and we don't want to mess with them too much, and we just want them to, or they're socially important, or they provide a fundamental infrastructure service. But I think one of the lessons here is that we don't solve this by allowing that approach to really high density resource loads in our cities. We have to connect them into housing. We have to connect them together between digital infrastructure, health infrastructure. Transportation infrastructure is the same. We'll be speaking later about some of the infrastructure implications of electrification of transit systems. Each of these things are big transitions in the way resources move through our cities. And we have to tie them together because power and heat and water are intricately tied together when it comes to hydrogen, when it comes to power, and when it comes to data and health, the stuff.
I'm going back to moths really quickly, just because you talked about water, because the byproduct of a moth, a metallic organic framework, have a look at it, amazing research going on in Berkeley, and there's actually a brilliant demonstration here, but is water. And water's what you need for cooling. So the whole thing, and actually can deliver clean water to communities. So again, if you think about all these things from a systems perspective, you start looking at the innovation, how you introduce it, you start rethinking sort of problems as kind of the potential solutions. You come up with some really interesting but very different ways of doing things. And the biggest challenge with data center developers is getting them to stop thinking about security because it doesn't work for sustainability, and start thinking about how security and sustainability can work together. It's mindset stuff, all of this. It's all mindset stuff. It's politics but it's psychology. So if you want to go and make a difference, become psychologists.
Thank you. That's not where I thought this conversation was going to go, but that's good advice, I'm sure. Thank you. We've got a few minutes left now, so I'd like to throw the panel to the floor. So if there's any if there are any questions from the floor, please ask away. I'll pass the mic.
Hi, Asif Din from Parkinson Will. Question for you, Dan. How do you marry up something which is almost a tenant-led environment in terms of, and then linking that with something which is infrastructure, effectively a long-term, long game? Is this going to turn into a sort of situation where you just have to keep on clicking to make sure that you've got enough heat in your home? In the sort of like the similar way that we had for, sort of waste to energy, is data to energy going to be something that's going to become more and more problem?
I doubt it. I think there's so much waste heat anyway that the issue is we can generate far more than the developments can use. I don't know if that's I'm really answering the question, but it's and actually I think that, Mark made the point that data centers are getting more and more intense. The computing is getting smaller, but the heating requirement and the cooling requirement is getting bigger. So actually, it's kind of growing. I looked at lots of different heat sources. Data center heat is there all the time, whereas many other heat sources aren't. If you use an aquifer, you've got to recharge it and all the rest of it. It's there in abundance. It's getting more abundant. I think in a way you deal with it through planning. The biggest worry in a way is that we just become profligate because the energy becomes quite cheap. The heat becomes quite cheap. People just don't keep their windows open and don't and keep the radiators on. And that's, and actually we're still using resources. So I think for me, that's the biggest sort of issue. How do we build good behaviors and deliver this technology? I'm not sure if I fully answered the question.
Yeah. Well, I think if the problem is how do we deal with too much heat, then I suppose we're moving in the right direction at that point, because given the affordability of warmth in much of the UK at the moment, that would be a much better problem to have than the ones we currently have. Can I ask, are there any other questions from the floor? No, I think that's it. So we've got a couple of minutes, and therefore I would like each panelist maybe just to give us some closing remarks. And I'll start with Mark. If you'd like to just give us any final thoughts, please, before we close the session. Thank you.
Yeah, please get this done before my life is done. So it's getting late. I just think that we know what we have to do. It isn't hard to understand it. It's hard to get it out and there's no paper. But I do think that there has to be, at least from everything I know, there has to be both a narrative statement and if there isn't, then we're not getting this. And I also think that one of the biggest fears that people have is making that change. If you think of data centers as a strategic asset, as opposed to even that.
Thanks, Mark. Brilliant. Rich.
Count embodied carbon, number one. Reuse the existing built environment where you can, number two. Buy renewable energy without question, number three. Reuse the heat, and let's change the way that we benchmark and measure data center performance.
Fantastic. Dan.
I would just say it's all doable. We just need to align interests and work as sort of teams. One of the things I get from here is we're all competing. And actually, I think the big opportunity is to align. And then this is such a massive, massive challenge we face, dealing with the the climate crisis, the inequality crisis, actually, the welfare, the well-being crisis, but also, and then the ecological crisis. We really need to start realigning and understanding that there are lots of solutions. We just need to work together to kind of find those solutions, and they can be, we can really sort of create change.
Thank you. And I mean, my reflections on the discussion that you've had, I think I feel quite optimistic this morning that the opportunities are there, and we have at least one example of where that's being taken into fruition, perhaps through force of circumstance, but it shows a demonstration of what's possible. And I think that point you make about working together, we know that there are some different ways we can measure and communicate these impacts. It's probably something that we as an organisation, and then more broadly as an industry, need to raise that profile so that people are aware of those, because it sounds like people are willing to listen if we can get the message through clearly and succinctly. And they, as you say, they've got money, so they can change their behaviours if it gives them the ability to continue delivering the services they want to deliver whilst achieving the environmental outcomes that everybody's looking for. So thank you very much for what's been a really interesting and diverse discussion, and thanks, Mark, for joining us. Really appreciate that, and thank you to the panels in the room as well.
Yeah, go and get some sleep, Mark.
Thanks, everybody.
Thank you, Mark.